In this video, we're going to do something quite interesting. We're going to do something called partial fractions. And if you are going to go on to do any calculus, it's a trick that you're going to need later as well. Now, it really is an algebraic trick. We're really going to be undoing something that we learned earlier in college algebra, even algebra 1. So let me show you here what the basis is for this idea. So do you remember how we had two rational expressions? Rational expression is just that it's a fraction. So what we would do with this is we would try to get a common denominator by getting them both. The way I would teach this to you is both of these need to be identical. So this one has x minus 3, so it needs x plus 2. But if you give it to the bottom, you have to give it to the top. This one has x plus 2, but it needs x minus 3. So if you give it to the bottom, you have to give it to the top. And so you would then distribute through here. The 2 is going to go to both of these. The negative 1 is going to go both of these. And you tidy it up and you get down to this. Okay, well, what we're going to do is the process of taking it apart. So here, what we've already known to do, and it's pretty easy, we're just going to put them together to combine two fractions, algebraic fractions. Well, now we're going to decompose them. And I tried to dive into, okay, what's the reason? Why does this work? And I found the old it's beyond the scope of this book reference. So basically, the proof is a little complicated, but it's based on the premise that any algebraic fraction like this can be done. That's the premise. That's as far as I could find. So unfortunately, I'm going to be presenting to you just a bunch of patterns to mimic without a real explanation. But so anyway, I guess it's quite complicated. So even calculus books were referencing it back to beyond the scope. So let's dive in and we'll take a look at how we do this, even if we're not totally sure the why. Let me skip let me jump to this first. So what we have here is the bottom of this fraction. Algebraic fraction is filled with linear terms. Do you see these would be lines? So they're degree 1. So there's two factors here, but they're degree 1. All right, so what we want to do is we want to decompose this, and here's how we're going to do it. What we're going to do is we're going to split those two factors apart, like we're going to separate them into two individual fractions. That's the root of how this game is played. Now, on the top, what we're going to do is we're going to say there's an I don't know over the first one and there's an I don't know over the second. Okay? All right, now as we do this, here's what's going to happen next. So what we're going to do is get the, how do I show you this? Yeah, let me show you like, okay, when I teach this, they're going to show a slightly different method. It is exactly the same thing as what I would be teaching you. But here's what I want to get at. If you get, hold on, let me show you with this. All right, if you were to combine these, can't you see right away? So this is supposed to be a 3. Sorry, that's terrible. So this would be a 4 for the value of x, right? Isn't this going to be 4 plus 1 equals 5/3? Because the denominators were the same, the denominators actually have nothing to do with this. Do you see what I mean? To solve the problem, all you need is to just really deal with the numerator. All you have to do is x plus 1 equals 5. That's the premise, that if the denominators in an equation are all the same all the way across, it's irrelevant. Now, the textbook is going to multiply by that denominator all the way through. It's exactly the same thing. But when I teach this, I say to do it like this. I think it's easier to understand. Let's get all the denominators the same. And when the denominators are the same, let's simply ignore them. Now, if you do something to the bottom, you have to do it to the top. So anyway, let's get down here to what they're doing. Or actually, let's do our own here. No, we can just jump right here. So, do you see what's happened? I wanted an x minus 1 here in order to get all the denominators the same. So I had to give it to the top right here. If I give it to the bottom, I have to give it to the top. Now here, what I need is an x plus 2. Give it to the bottom, and I give it to the top. Now, all the denominators here are the same, and so they become irrelevant. All I need to do is work with the top, and here's my top. I've got 3x equals a times x minus 1 plus b times x plus 2. Okay, so what have we done here? Well, let me show you. Let's distribute that. and we get this. So we're just sending the A through, sending the B through, and we get this. Now, here's what they're going to do next. We're going to combine the x terms. Now, I know it's weird. You can't really put A and B together, but you get A plus B all times x. And we're also going to combine just the regular number. Oops, yeah, regular numbers here. It'd be negative A plus 2B. Now, what have we accomplished? Well, what's happening here is that there is some coefficient in front of x. It must be equal to the 3, right? This part is never going to turn into 3x. That's impossible. So here's the trick. We're basically going to put the coefficients in front of the x and match them up with the coefficients in the answer. So a plus b is going to match up with 3. Negative a plus 2b doesn't have any number. If it had been 3x plus 2, then negative a plus 2 would match up with the coefficient 2 here. But it doesn't. So basically what we're doing, we are putting together the values that are with the x's with anything in the answer that has x's, the coefficient. We're putting anything that's just a number with anything in the answer that's just a number. So in this case, a plus b is going with 3. Do you see? Whatever this is has to turn into some version of 3x. Now, negative a plus 2b doesn't have anything to turn into. It must turn into 0. It must drop out. So we're matching the coefficients with the coefficients in the answer. Okay, so if you're following that, you look at this and go, well, what good has this done us? Well, now we have a system of equations, and we're going to be able to find what a and b are. Yeah, if you see here, we could do this of any method that we've learned. What I would do is I would do elimination. I would just add these up. The a's would instantly drop out. So if the a's drop out, you're left with 3b equals 3, and b is 1. So if you know b, you can then plug it back in to find a. And you've got b is 1 and a is 2. Okay, well, what good has that done us? Well, look back what we started with. Well, it's all crowded here. Let me just jump to it. So what we started with was this had been a and this had been b. That's what the very first step was. We broke this up into a and b over the individual denominators, individual factors. Well, we know them now, so we've figured out a way to break this apart. Now, hopefully we got another one here. Okay, let's try another one. So what we're going to do is this. We're going to break this into some value of a over x minus 3. And we're going to break it into some value of b, x minus 2. So we're decomposing it. We're taking it apart. We're trying our best to do the process in reverse. Okay, now if we've done this, what we're going to do is we're going to go through, we're going to make all the denominators the same. That's x minus 2. Do it to the bottom, we got to do it to the top. This one needs an x minus 3. Do it to the bottom, we got to do it to the top. Now, if the denominators match all the way through, they are irrelevant. And so what I've got now, I'm going to go ahead and just, well, I better not. I'm going too fast. This is hard enough without me trying to save time. Okay, that's what I've got. The denominators did not matter. Now, let's FOIL this through. Okay, now what we're going to do is we're going to collect the terms that have x's in them. So, yeah, they didn't show this step. I better show every step on this one. Maybe I'll take some shortcuts coming up here. So I have grouped the x terms together, and I've grouped the non-x terms. So just our basic digits here have come over here. Okay, now let's got one more step here. We're going to do, just going to think of it like it's a GCF and pull that out. Okay, now we're ready to go. Now, the a plus b must turn, there's a 1 here. So the x terms have to turn into 1x. Do you see what I'm doing here? So we're going to say 1 equals a plus b. There's an x here and an x here. So the a plus b must turn into a coefficient of 1. Now, the negative 2a minus 3b must turn into 0 because there aren't any of those over here. So it must turn into 0. All right, now we could solve this. This should be a b there. We could solve this any method we want. Yeah, we could do this multiple ways, but I'm going to run a 2 through the top here and make this 2 equals 2a plus 2b. And then I'm going to add them up. So if I did that right, I've got negative 1b equals 2, so b must be negative 2. Now, if that's what b is, I can just use this equation on the top to find a. 1 equals a minus 2, so a must be 3. So I've got it. I've got my values of a and b. So let's go back. The way to decompose this is 3 over x minus 3. Remember, this is what we started with. We said a over x minus 3 and b over x minus 2. Now, you could have written this as 3 minus 2. Anyway, I'm sure if you're this far in the course, I'm sure you understand what I mean. But so we've decomposed it. Okay, now things get trickier, and again, I don't have the proof of this on why this is necessary. I'm going to trust their judgment here. But if we have a repeated factor, so let me jump to it. So we have linear factors. Let's, hold on, they're making us factor this down. Yeah, they didn't factor it for us. Okay, so the additional step here would be that we haven't gotten this factored. So pull out an x here. Okay, so do you remember this factors down to x minus 2 squared? Okay, so one of the pieces I've forgotten to mention here is that this trick will work if the numerator has a lower degree than the denominator. Notice this is x to the third and this is x to the second. So we're good. This can be done. Now, what's happening here is I have a factor that repeats. Now, they're linear factors, so they're degree 1, x, x minus 2. These are lines. These are linear. Now, this one repeats, however. And because there's a repeat, we have a trick we have to do. What we're going to do, so this is the first factor. One of our factors was x. We broke them apart like we did last time. Make this an x. Now, what we need here is we need to adjust the fact that there's repeats. We're going to list the factor once. So x minus 2 one time, and then we're going to do x minus 2 two times. So up to that, so it was repeated. So we've got to do the degree 1 and we've got to do degree 2. Again, I'm sorry I don't have the proof of why that is, but it is the case. So now we have this, and now we're ready to do. So let me back up. So again, we have to have a lower degree on the top, and we do. Now I just factored it down, but we had a linear factor. All of these are linear. So they're degree 1. All of these solutions are degree 1. We just have a repeat. So what we've added this time is the first factor. So here was just the regular factor. This was nothing special. We just put an A over that. Now this was the factor that repeats. So we do it once with a degree 1 and another time with a degree 2. Now we're going to follow the same process. Where can I do this? So I don't know where to show you this because I don't have a lot of room. But so here's what would need to happen. This is going to need 2x minus 2's. So we want to get a common denominator here on the right. This needs 2x minus 2's. So I give them 2. But if I give them to the bottom, I got to give them to the top. This one needs an x and an x minus 2. If I give it to the bottom, I've got to give it to the top. And this just needs the x. If I give it to the bottom, I give it to the top. I have to make all the denominators the same. Now, that brings us here. Okay, so they're doing it differently, but it's the same thing, and I like my way a little better. So this gets us to the same point. Our denominators are all the same, so they no longer matter, and I now have this equation. Okay, so we've got some foiling to do and combining like terms. This is just foiling it out. That's all it is. And so foil it out, do the rearranging. Here's what we get. We've got an a and b in front of an x squared term. We've got all of this in front of the x term, and then we have just 4a. But the pattern is going to follow. Look here, I had x squared on this side I have negative 1. So I'm going to have the formula a plus b equals negative 1. Here, negative 4a minus 2b plus c is going to match up with this 2 in front of the x. And 4a is going to match up with the 4. So here are those equations I just described. All we're doing is matching up, like we did before, the coefficients. That's all we're doing. Now we can instantly solve this last third equation. A is going to be 1 just by dividing by 4. So we know A, we can go to the first equation at the top. So if A is 1, B is going to turn out to be negative 2. That was easy. Now we know A and we know B. We can use the last equation to find C, and then we've got it. So remember that it was A, B, C. Oh yeah, so just be careful here. The b was -2, so there the negative sign is right here. -2 plus 2. Okay, let's try one. So they were a little nicer to us on this one. This can be done. This would be x squared on the bottom if you FOILed this out. And so we have a lower degree on the top, so we can do this. So we're going to do 6x minus 11. It can decompose. Now, whoops, that was supposed to be a 1. Sorry. It can decompose into a over x minus 1. So we're going to do that factor with a degree of 1. And then we're going to do that factor with a degree of 2. Now, our next step is we want to get the denominators the same. So this one has 1x minus 1. He needs another. Give it to the bottom. Give it to the top. Okay, so let's FOIL that out. Well, I should do this first. So the denominator no longer matters. It's irrelevant. Okay, so now let's start FOILing through and tidy things up here a little bit. This is going to be ax minus a plus b. Now, all of our terms are already together. Normally, we would order together the x terms and everything else would be separated, but it's already done because there's only this one term. So what we know here is that a is going to be equal to 6. So I'm matching that with this coefficient here. And I know negative a plus b must be equal to negative 11. Okay, so I've got a is 6. So I've got negative 11 equals negative 6 plus b. B then must be negative 5. So all that's left is let's write it in a decomposed form. So a turned out to be 6. And, oh shoot, I did that again. Hold on. I should write it like this. A turned out to be 6, and b is negative 5. So we should be writing it like that. And we've got it. We've decomposed it. Okay, so that is your introduction to partial fractions and decomposing a rational expression. I'm sure we're going to have some more of that in the next section, but hopefully that made some sense.